profile, his transaction, where he currently clicked at, etc. That's what you throw in. And then the API will immediately return to you the prediction that it calculated in a JSON format. So you can even do it straight from your website, for example, through JavaScript, and then get the prediction back. Here we have a linear regression algorithm that we used where the predicted value would be numerical, and it would give me back that predicted value straight away. So this is a great way if we want to get real-time predictions through it. Now, in terms of machine learning algorithms, you probably know all of this, but I just want to run through it. These are some of the more common kind of algorithms that we see. Classification, things like put things in a bucket. I have a predefined bucket, like a gender, like an age ratio, like a yes or no question. That's a classification. A good example of that is sentiment analysis, like something that became very popular on social media. Is that person tweeting something good or bad about me or something neutral? That's a classification problem, right? Saying I have good, bad, and neutral as classes, find ways of determining what puts in where. Another algorithm is linear regression, so predict a trend, right? Things like what's my sales revenue for next month, for example. A good other example of that is, I always say, if you ever used Excel sheets and you created a graph and you right-clicked and say create trend line, that's a linear regression right there, all right? Now, those are the two algorithms that are currently supported in the Amazon Machine Learning Service. We're looking into including other machine learning algorithms further into it too, also relying on your feedback here. The reason we chose those is because it's obviously fairly easy algorithms to say what is my target variable. Now, sometimes we also look at clustering algorithms. So if you think about something like Amazon.com, other people bought this, like a recommendation, that fairly often translates into a clustering algorithm, something like a k-means, a k-nearest neighbor. If you want to do that, you obviously got R and also other open source libraries like Spark MLlib and Mahout. All can be run fully managed in Amazon EMR. So that's a great place to get started if you want to say, I want to do a clustering algorithm, k-means one line in R. I want to do it distributed on massive amounts of data set. I can do it through EMR. Another one is obviously association. If you go to a Family Mart or a Kmart or 7-Eleven, you use that algorithm on a day-to-day basis. You just don't know about it, or that better said, they use it against you. What is an association algorithm? Market basket analysis is a very traditional, common one here to find similarities between products. For example, if I buy a bottle of Coca-Cola, I'm very likely to buy a bag of chips, for example, if I have a certain profile. Right, that's a market basket analysis, so bundle products together. Again, those association algorithms, obviously, you know, they're available in R and Spark and Mahout, so they can be powered through EMR at scale. And then lastly, if you want to train neural networks, so neural networks, things like pattern recognitions, for example, like speech recognition, neural network, literally training a brain in a computer, roughly speaking. For those neural networks, sometimes it's useful to use the graphical processor unit of servers, the GPUs, to kind of train neural networks better and do so really fast. If you require that, I want to point you to the fact that for our virtual servers, we have different kind of EC2 instance types. Some of them have more CPU, more memory, and so on, more storage, optimized storage. And we also have specific GPU optimized instances where you can actually tap onto the NVIDIA, we use NVIDIA GPUs, use CUDA language and run your neural network on those GPUs. Yes, R has integration into it, if that's your question. So you can, you just need to import a certain library and then you can use CUDA language to tap onto GPUs within R, for example. You want to do that? A GPU optimized DC2 instance might come fairly handy. All right, how about, question? Yeah. So how many kind of? Right, so how many clustering measures we have? So currently the machine learning, the fully managed machine learning service only touches on classification and linear regression. Right, so clustering currently is not part of it. For classification, it's, yeah? Right, so in terms of clustering algorithms that we see, it depends on the project that you're using. So, right, so it depends on the projects you're using, what clustering algorithms we have. Spark MLIT is an example. So Spark MLIT, I think you get k-means and KNN and some, you get a bunch of, don't quote me, look at the list and so on. But there's obviously when you run R, you get all the benefits of R, and depending on which library you include in R, that defines which algorithms you have. And then another one on EMR is called Mahout, M-A-H-O-U-T, which has lots of interesting naive Bayes algorithm and things like that. So it depends which project you're using. For the service itself, it doesn't include clustering for now. It only includes classification, and this is binary, so 2 buckets, or multi-class, so multiple buckets, and linear regression. Good question. One last thing that I wanted to discuss is the visualization aspect of it. So obviously we have business intelligence tools and so on. I wanted to demonstrate that some open source tools can come in quite handy. One that I quite like, especially when it comes to log analysis, is called Kibana. So Kibana was a project that was created by a specific person, and then eventually became really popular to a point where a company was founded around it, which is now called elastic.io. And it's an open source project that allows you to do nice visualization in browser like this by tapping on an indexing engine, which is Elasticsearch, which is an indexing engine which is based on Apache Lucene, another open source project that has been around for, I think, over 20 years now, nearly. The good news is Elasticsearch can be fully managed and even run on Hadoop so that it can scale, and then Kibana can start visualizing that information quite nicely in browser. Here's just a sample dashboard. You can create your own dashboards and filter things around and click through those dashboards, and we're going to have a little demo on that in just a bit. Open source, so github.com/elastic/Kibana. This is where you can find it. Now, what I wanted to do is just show you a little demo on how we could put this together. So, So what I figured is, how about we create a little live demo where we actually work on large amounts of data. So one thing that comes to mind is obviously Twitter. So with Twitter, we get, this is a 2013 statistics, by the way, we get about 500 million tweets a day, and an average is about 5,700 tweets per second that we see with Twitter. So how about we put that into an Amazon Kinesis stream, and then from there we pick it up with an Amazon Lambda function so that we can operate on all the individual tweets that are coming into our Kinesis stream. And then I'm going to look for hashtags, and those hashtags I'm going to index them into an Elasticsearch appliance, and that will then allow me to visualize them in browser with the help of Kibana. So let's try this. All right, it's a live demo. So let's see if it works. Just test my connectivity. Perfect. So what you see here, before I proceed, this is, by the way, the AWS Management Console. So here you see you get all the kinds of different services that we talked about, like EC2, S3, EMR, machine learning, etc. This is how you can interact with AWS out of the console, apart from the API. So what I'm going to do first is, because we want to feed this into a Kinesis stream, we going to look at Kinesis. So I actually pre-created this. Let's just click on it. I created a Kinesis stream. So it's just loading up. There we go. I created this stream which I call Twitter demo stream. So this is my first point of entry. This is where my tweets can come in, and if I click on it, you see it also gives me some statistics around what's going on in that stream right now. You see that right now nothing is in there because I haven't started tapping onto my Twitter feed yet. Now, the next thing that I want to do is, if I use a stream like this, that's great. It ingests my tweets, but what am I going to do next? I want to find the hashtags. So I need to write my own little code. How do I make sure that gets executed upon every event in my Kinesis stream? Well, I use event-based compute, which is, I'll go back here, which is Lambda. So Lambda allows me to run my own code in response to events. And that event is a new item in my Kinesis stream. So what I've done here is I created a Twitter demo Elasticsearch Lambda function. So let's open that one up. And you see this is actually Node.js code. So I could have chosen Java, it shows Node.js here. You can see there's an inline editor. You can also upload it obviously as a packaged zip file if you prefer that. What is this piece of code doing? Let's have a look at it. So basically, I get an event which comes from my Kinesis streams. And this Kinesis stream has records. So the records that's streaming into this Kinesis stream. For all of those records, I'm just going to take them out. They're JSONs, because it's a tweet, it's stored in a JSON format. Some cleaning here, they're undefined or whatever. And then I'm going to look for hashtags. So I'm going to find those hashtags and put them in a hashtag variable. I package that back up into a JSON here, add some additional information like date, when that currently happened, extract things like what was the topic that was talked about in the country, etc. And then here I'm going to put it, and you see this is a single server Elasticsearch appliance, I'm going to put it into an Elasticsearch appliance for it to be indexed. How do I do that? Elasticsearch is a RESTful API call, so I just need to use an HTTP call. You see that here. This would be using the Node.js library of HTTP to make that request, and if it was successful, then we indexed the hashtag into the Elasticsearch appliance. So how do we execute this now? Well, we want it to be executed upon every event within Kinesis. How do we do that? Well, we collect that Lambda function to an event source. You see I've already done